For over 50 years, the Navy has operated C-2A Greyhound cargo haulers with twin turboprop engines to ferry personnel, supplies, mail, and spare parts to its massive aircraft carriers at CA, a mission known as Carrier Onboard Delivery, COD. The Greyhound, which is derived from the Navy's E-2 Hawkeye radar planes, can haul up to 5 tons of cargo or 26 passengers while still managing to land and take off from the 300-meter-long carrier flight deck, and then fold its wings to fit in the hangar deck below. In the late 2000s, however, the Navy began looking to replace the aging Greyhound. Candidates to take up the COD mission included modernized C-2S and the Navy's recently retired S-3 Viking anti-submarine jets. In the end, though, the Navy gave in to urging from the Marines and decided to pursue the most expensive option, the V-22 Osprey tilt-rotor aircraft. The Osprey has been in development for decades, and the promise of its revolutionary and exceptionally flexible helicopter-to-airplane flight capabilities have been tempered with concerns over deadly accidents and high procurement and maintenance costs. Let's just say this change is less than universally acclaimed. Still, the V-22's strengths are big deal. The nacelles of its twin Rolls-Royce T406 turboshafts can rotate 90 degrees, switching from vertical helicopter-like flight mode to a horizontal airplane-like configuration. While surface ships love the flexibility of using helicopters to land and take off from virtually any cleared deck or surface, helicopters are limited to significantly lower altitudes and speeds, and can't fly nearly as far as airplanes. For example, a typical Black Hawk helicopter has a maximum speed of around 170 to 200 miles per hour and a range of 350 miles, while the Osprey can attain 350 miles per hour in horizontal flight mode and fly up to 1,000 miles away. The V-22 program has been under development for over 20 years. Safety and maintenance concerns have arisen during this period, but the program has maintained support from many in Congress nonetheless. The program has undergone restructuring to accommodate recommendations from outside experts and DoD managers. The feature that most sets the Osprey apart from almost everything else is the fact that it is a part helicopter, part conventional airplane. The Marine Corps' AV-8A Harrier was this country's first operational vertical takeoff and landing (VTOL) airplane, but the V-22, originally known as the JVX, will be the first large-scale effort to employ tilt-rotor technology for vertical and/or short takeoff and landing (V/STOL). While on the ground and while hovering, the Osprey's engine nacelles will be perpendicular, and the large-diameter rotors parallel to the wings. After takeoff and for straight and level flight, the rotor/nacelle combination will rotate forward 90 degrees, allowing the V-22 to fly like a normal airplane at speeds of more than 300 knots. It is precisely this neither fish nor fowl configuration that will make the Osprey such a versatile performer. The V-22 is the first major airplane project to be designed entirely on a computer. With computer-aided design, CAD, engineers were freed from having to draw a multitude of blueprints and could easily make changes in the design. Another great advantage to the CAD system is that it allows designers at Boeing Vertol's plant in Philadelphia, Pennsylvania, to communicate instantaneously with their brethren in Bell Helicopter Textron's Fort Worth, Texas, facility. The two companies have split the work on the V-22, with Boeing Vertol being responsible for the fuselage, empennage, overwing fairing, and systems integration. Bell is building the wing, nacelles, transmissions, and rotor and hub assemblies, and is handling the integration of the Allison T406 AD400 engines. These engines are a derivative of the T56 engines that power the Grumman C-2A and E-2C and the Lockheed C-130 and P-3 aircraft. Other features in the V-22 include a sensor track handle in the middle of the console to let either crew member operate the forward-looking infrared radar (FLIR) system. This control was added to the console instead of located on the stick to prevent the flight crew from fighting with each other while one was flying the plane and the other was operating the sensor. A 2,000-pound capacity fold-down winch, standard in the Navy's Combat Search and Rescue HV-22A variant, will be available as a kit for the other versions. The 12 aircraft of the initial run will be MV-22As, and the first of the additional 540 aircraft in the Marines order will be delivered in early 1992. The first of 50 HV-22, as ordered by the Navy, will arrive in mid-1992, and the Air Force will get the first of its 80 CV-22As at the end of that year. The Army, which will use MV-22As for utility and medevac missions, will get the first of its 231 aircraft in early 1993. While the total buy of 913 aircraft, at approximately $16 million each flyaway cost, will keep the two firms busy until the mid-1990s, there is considerable discussion of an additional Navy order for 300 Ospreys to replace the Lockheed S-3 Viking in the anti-submarine warfare role. There is also the possibility that the Air Force could order more of the aircraft for either the SOF mission or for combat rescue, given the cancellation of the HH-60 Nighthawk program. One further role under discussion for the Osprey is as a replacement for Marine One, the President's VH-3 helicopter. The V-22 Osprey might appear to some to be a novelty, but the technology is mature, and the support is there from all quarters. It does indeed appear that there is no limit as to what the Osprey can be made to do.